it's happening. It's happening. Absolutely fabulous. Oh, goodness. Oh, help me. Oh, welcome. Welcome. And last we were here, we were checking the feasibility on fitting in 4 assemblers into a Mark II blueprint. Looks like it was feasible. We also checked the feasibility of, looks like two manufacturers. Very good. Very good indeed. Welcome back. It looks like we're building a factory that builds a factory today. Like we do every day. Help us, we're trapped. We were thinking about producing radio control units, which combine computers, all-clad, and oscillators. Okay, let's just do some upgrades, right? Just good old-fashioned upgrades. Silly old upgrades. And honestly, can we please delete the hub and bring it with us for once? Ever for once? Wait, aeronautical engineering requires 50 of these? Is this the best? Oh, gosh. So we need to produce these radio control units, is what you're saying. Trapped. I feel trapped. I feel trapped. No, I know what you're thinking. Yeah, let's get those radio control units. Caterium computers. Last we were checking our plans at satisfactorytools.com. Did we get pictures of this? That'd be really easy. Here we go. So you can see here that we'll produce 3 computers per minute-ish. Use my zoom. Through alternate caterium computer. And we just require water, caterium, and copper inputs alongside rubber and plastic. So it's caterium and copper holding us kind of hostage near rubber and plastic. Let's just say we're going to build rubber plastic by SATISFACTOry as well. Do we have everything we need for that? Let me just check the recipe. That's not the recipe. Goodness. Oh, I see. I need to minimize. It's too bad paint doesn't get its own thing. So you start with heavy oil residue. Got it. Heavy oil residue, which goes to residual rubber, diluted fuel. We need the diluted fuel alternate recipe. So we add that to the to-do list as well, right? Like hard drive scan for diluted fuel. And that's for rubber and plastics for future. And for caterium computers. Now, you know. Let's begin that hard drive scan right away. In the local MAM. We have 3 hard drives in inventory now, so we can afford a little bit of scan. And we'll try to find diluted fuel. Cool. Okay, where were we? That's diluted fuel. Diluted fuel goes into recycled rubber at the refinery in a loop with recycled plastic. Right? So let's get... Let's just check our recipe bank. Recycled rubber, check. And recycled plastic, excellent. Those recipes... That's all. That's all that's needed. It's the 2 recycled plus diluted fuel in the blender. Pretty good. So we're doing the hard drive scans for rubbers, and for now, let's look for caterium and copper together. Other oil is okay too, like any oil source is fine. We're going to start somewhere. But caterium and copper are the important part. Here's the vanilla map. Here's copper. Here's caterium. Here's crude. I don't believe we can yet make the pressurized or the pump. No. So this has to be natural crude. Here, north of us, is a pretty appetizing location. Loaded with crude here that's kind of obscure. And kind of central to caterium. Oh, tons of copper around. Yeah, tons of copper. What about this location here? Where we can draw on all three? Where's the water? Where's the water? Yeah, where's the water? Honestly, the location we're working now is pretty appetizing for rubber and plastics. And it offers the water we need. See, the rubber and plastics, they get produced independently. And the oil can be shipped, like we're making these rubber and plastics here. Let me just take a screenshot. And we can plan on the screenshot, right? Here we go. Oh, no, this. Plan looks good. Don't need this. Here we go. I was proposing... Yeah, this is going to be a little tedious, but we can do this. I'm proposing... plastic rubber. Here. And then move it by train to caterium copper, which are here, right? Loads. So here's the water source for them. We just need to investigate. Yeah, it becomes the fused quick wire. into caterium computers. And we could do caterium circuit boards as well, separately. Nice, and that's where a caterium computer goes. And it's a railway. That's a railway to drive from one to the other. We have this rail already. Right, we have some rails. So let's just bring we'll bring plastics and rubbers this direction by train. Pretty compelling. Yeah, pretty compelling. And the resources we want to use right away. Let's just circle those. Yeah, exactly. And the spine would look like this. Yeah, and that would be the caterium computer bite-sized factory. That's kind of the plan I'm thinking. It's close by, and there's a ready source of water. We just need to evaluate the water. Let's make sure we address some of the key issues here. Oh, excuse me. Oh, wow. Let's see what water access is like there. Let's just jump into the game here. And from the map, well, let's just take a look here. Yeah, we are heading to copper 1 here. Let's take a look at our version of the map. Latest save. So what options do we have here? Yeah, we have 2 copper miners running here. A few other little copper nodes here to pull in. But even better is we've got a freight platform here to move goods, all ready to go. How far does this hypertube come out? Real far. So take the hypertubes all the way in. That's what I heard. Come on, hard drive scan. Okay, rescan. Come on. Buy coal. Turbo blend fuel, you got it. Alright, scan the hard drives. We're looking for hard drives, it turns out. We need diluted fuel in order to do our rubber loop. Yeah, that's the T. Hard drive scan needed. It's just you gotta do what you gotta do. Those recipes get us everything we are. Alright, take me in number 1. Quickly. Wait, how's my inventory in general? It's kind of trashy. Check for the trash level. Yeah, is there any trash in there, sir? Tons of trash? Okay, could you please unload your pockets? Step onto the belt, please. Garbage. Valuables. Hoggy parts. Spitter parts. No, keeping summer slips, thanks. And the trashery of it all. Travel trashery. I don't even think we need these filters to be real. Casing, thing of the past. 4 rods? No, I don't think so. Thanks, though. And what are we holding on to now? Aluminum ingots? Oh, there's a few items I can tuck into the aeronautical engineering milestone. Hold on. That's some real crap there. Whoa, there's a bunch of little weird chests here. Do people know about this? Nothing in there. What's in there? Oh, all kinds of trash. What's in here? Nothing. And what's in here? Oh, trash. Nice. Okay. Let's satisfy the man, shall we? Or not the man, the actual research center, the hub. Remind me to break this hub before we go. Okay, nice. Nice. And it kept the progress despite me deleting the hub. Great. Oh, heavens. Oh, there we go. Yeah, we don't need any of this stuff, do we? No. We good. We good, thanks. Kind of fun. Whoa, so many goods. So much bio. Whoa. Is that just going to keep building up? Is that how that works? Wow, it's wild. Wild, Chad, I tell you, wild. My great energizers. Alright, I got lost fantasizing about the power in the factory. Let's go. Okay, we're going to the Brave New Worlds. Go! Go! We used up a lot of Mercer spheres in the time since we were out. Yeah, well, time, technology moves along. Like the ebb and flow of time itself, technology's wave runs against the shore, splashing against the tips of those adventurous enough to taste its energies. The usual. Ain't you never seen a naked chick riding a clam before? Ooh, back up to the high ground. We love riding these tubes, Chad. Slipping and sliding. 2 fingers full of Vaseline on every tube. Oh god, spiders. God, that scares me every time. Can you see our mighty factories from here? Maybe. It's kind of fun that we're running this factory at the ground level in a way that we can, like, see and interact in a fun way with the... with the real design of the game. You know, last game I built a sky factory as soon as I could. I couldn't be bothered to go up and down and, you know, the clipping. I think it's cute, actually. It's kind of a beautiful part of the game. And to be able to enjoy the scenery here no matter what, that's... I think that adds a lot to the game. Whoa. Yeah, you gotta watch out for that. Is that not powered yet? Why is this always the maiden voyage? I'm not even joking, Chad. Like, is this another maiden voyage? Have we never come this far? Okay, it's working. Oh, do a little research here. Perfect. Oh, diluted fuel. Oh my goodness. The luckiest, absolutely luckiest stars. When you wish diluted fuel. Do we use the last hard drive just for the absolute gigs and shittles? No. No. No, we don't. We're proud that we got what we got. Right? Hard drive scan. Success. Why are we so good at this game? Oh. There we go. Hard drive scan diluted fuel. Bing bang pong. The caterium and copper are here. But are they available? Okay, I got pooped out way down here. Is that the deepest deep? Yes. So we can head to our train station. No, not Bauxite 1. Copper 1. That's right, Copper 1. Okay, here we go. Is it bad to go this direction on this particular rail? I don't think so. What does the map say? It's like, is this east-west? Yeah, I guess it is east-west. Getting less clear, but it's all motivated. Yeah, I'm fine with this. I'm fine with this. I find this acceptable. Chat, I find this acceptable. Oh, goodness. Alright, it'll be a maiden voyage on this again. We always making progress. Like, I don't think there's a reason to even stop here. We only stopped here because we needed something. And now there's an office or whatever. I don't know. I'm building from here. We're not stopping. We've scoured for drives all around here as well. It's not a secret. Okay, see, here's the problem. You don't get the hypertube for free, right? Why is it so radioactive? Whew, sheesh. There's no power there, eh? Oh, I see. There is. Like, kind of. Yeah, north. I go north, and then I go directly... I mean, I follow the railway is the truth. Wish I'd followed the railway the first time, honestly, like... Yeah, this is still reasonable. And then east. Solidly east. I feel like we've been through this dangerous zone before. We don't really want no trouble. Yeah, let's take it all the way to the edge of the cliff. Just to where caterium exists. Oh god. This is horrendous. Sons of bitches. They got us. Get it. They're not very sticky. Just wait for him to land. He's gonna land there. It's tough to land these, eh? There he is. Got him. I don't know why we worked so hard to kill those two spitters, though. We've had enough, actually, is what I'm feeling. Frankly, we've had quite enough. I can see. Once a piece. Huh. Get hoggied. Absolutely Hoggison. Wait, who? Love it. Love this gun. Love this gun more than life itself. Awesome. Moisture spheres, love it. Yeah, spiders are no problem now as well. Wait, isn't this quartz? Hold the phone a minute. Caterium, if you please. Oh, I see. This is where the factory dumb plum go. But off in the plum distance, this is where the plum magic happens. This dumb plumpkin. Just show me the caterium. Kind of beside me. Whoa, is that a... just another moisture sphere here again. Wow. Casual. Oh, sluggy. Is the caterium in the cave? Alright, spiders, come and get it. You don't scare me. Whoa, who's that? It's kind of like he's stuck or something. Oh my god. He was leaping at us as he died. Okay, those are some huggy parts if I ever did see. Is there a caterium in here? God, Jesus, where? No problem. No problem at all. We'll just get some power lines in here. It's weird that my hover pack is getting powered from above the surface. I can't see the jetpacks that are working, but they're working. This appears to be another breakaway in here. This place is loaded with slugs. Nope. There's the first clue. There's caterium right there. Okay. Okay, that didn't quite do the trick though. Where? Where, though? That is so unnerving. And there's the caterium. There he is. Got him. Nice. Also, our slug. I'm sure there must be summer sloops or mercer spheres in here. Pull a little power here. Patience, Iago. Patience. Oh, excuse me. There's them caterium sources. So how do we get them out of these freaking caves as well? Not the easiest. So many slugs in this cave. Is it because there were huge spiders? They're just like justified. They're like, here, take this. Take these! These are some precious cateriums right here, yeah. Liner Mark 2. And where do we go with these? Straight up. Straight up and out, yeah. You get up to this shelf. And then you get up to this shelf. And then you're kind of getting home free. That's it. That's it. That's it. That's it. Here, let's just like show a path as well. Please hold. P time. Let's extract some caterium. We'll be glad to Mark 3 this. I mean, oh, who's that over there? That spidery carcass in the distance. Goodness gracious. Finish him! How come they're not jumping at me? I feel like they're confused in the cave. Oh, nice. Get him. Oh, that's a good one. That's good, spider carcass. And what other goods behold us, my lord? These slugs, of course. But, like, actually, like, why are people coming in here? Isn't there a summer sleep or something? Alright, let's get that Sluggington. That's ours for the taking. Thank you. Surely there's a spider just ready to fight us off on this, right? No? Nothing? Damn, they've lost their will to carry on, eh? Oh, here's some pure caterium for fuck's sake. We'll figure out how to get out of here. Four and 5. I think it's time to update the recipe standard on 4 and 5 to be Mark 5. 4 and 5. And here's Mark 4 as well. Let's go Mark 5, 4, and 6. This should be 5. And then foundation should be 6. Let's just say that there will be a merging. Oh, it's all 3. Look at them here. Oh, for heaven's sake. Succulent. Mark II miners all around. One, 2, 3. Perfect. Invalid placement, excuse me? Oh. Oh dear. We must remove those pieces of caterium outlying the deposits. They interrupt the flow of the belts, my lordship. So there's every reason to believe that in the future, people will walk on their hands. And then this. How do we get out? We're close, right? Yeah, it's right here. It's literally right here. I'm making the pathway a little more deliberate. Just to help out. Wait, this isn't the exit. This is some other horrible entrance. Hold on, hold on, hold on. This is the exit. Yes, 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 yes. Yeah, and we could choose the belts here. Yeah, 3. Let's just say we're moving multiple items here. 1, 2, 3. And we're heading for... Yeah, absolutely. 1, 2, 3. Secret cheeky little caterium pocket, isn't it? You don't even realise it till it's a cave, isn't it? Sorry, I know the accents are offensive. I know. Leave angry messages in chat. Honestly, I need to learn. If you don't tell me, no one is. Seriously, this is just gonna keep going. That's not a threat. That's just like a truth about oscillations. Okay, and who's this that we're accidentally building upon? There's a casual quartz deposit we did not... Oh. There's 2 quartz deposits here. What? Oh. The spheres. Wow, that puts us back up to 13 spheres. Knowledge.
Harvest the scripture. Compose it into a blood song.
Who? Who needs a piece? You, Hoggy. Well done. Well done. Who's that? Get him. Uh-oh. Uh-oh. Got him. Nope. Get him. Get him. Get him. Got him. Where are those hoggy parts? Yeah, nice work, everybody. It was just a Mercer sphere, and then it evolved into some extra hoggy procurement. Yeah, let's say that, let's say that rubber and plastics both came in on the train. Our first job is to do the rubber and the plastics, yeah. And this is the train, right? Where's the train? That's how this is going to work. We're going to bring in our goods via the mechanisms we already have. Where's that train, though? I'm for real. Here it is. I see. Okay. Okay. Is this too far away? Oh, that's the thing. You need to establish it water because you're generating pure copper and pure caterium. Hold on a sec. We need to check the water depth here. And then I think we're going to do a bite-sized factory for oil and rubber. That's just the best play. Okay, we need some power here. Yep, great. Yeah, it does look deep enough. Let's try some water extractors here. Oh yeah, absolutely. Wow, tons of water extraction possible. Okay, especially for space efficient, this should look quite good. What are these guys guarding? What are these guys guarding? Sick. Absolutely sick now. Not sure what they were guarding here. Something we likely already stole. Alright, so now, given that we do have access to water, power, it's just a matter of bringing the caterium over. Just from up here. Yeah, let's take a look. That's going to be right around here. Here. Just in front of the big tree, right? I'm going to drop a mark here. Alright, let's go. Who's fighting? No, I don't think so. Ah! Triple Hoggingston? Nope. Next. Dang, these guys are resilient. I'm gonna throw a grenade pretty soon. Got him. Who's Hoggy? Got him. Oh man, that is a slaughterhouse. He got hogged up? Yeah, he got hogged up. Too hoggy. Yeah, I think we should take our hypertube to this location as well. I'll bring out the hypertubes to here. Copper 1, oil, copper 1 at old base. It's copper 2, eh? Wow, there's just a huge moisture sphere right there. Juicy. Waiting. Yeah, where does this guy go? Elsewhere, I would say. That's 2 pipes and the third right over there. Quick switch is bound to nothing. Is that the tool I'm looking for? Options. Key bindings. Quick switch. Well, that's it, yeah. Alright, we'll head to oil and we're going to solve rubber and plastic now. We got the hard drive we needed, which means we can permanently solve a closed loop solution for converting fuel into rubber, into plastic, in an absolutely closed loop. Diet Sprite root beer. No, it's just Diet Sprite. Ooh, and my favorite snack, a few peanuts are here to join us this evening. Damn, there's so many enemies in this jungle. It's nice not to walk. It'd be nice to project ourselves, but I also just like the ride. I don't want to be hands-on the whole time. I like to think and talk. I might not have to be clutched on like a captain in dangerous waters. Besides, there's going to be plenty of clutch in here. There we go. This is a bozite source. And, yeah, just in case you need to check bozite or upgrade bozite. This, I'm not sure what this is. Just looks like suspicious activity. There's some kind of thing over here? Maybe this is the iron. No. Or copper, sorry. Is it like one of many coppers? No. I don't know. I don't know. There we go, it's over there. A lot of nexuses to get where we want to go. Into these obscure, distant places. Understandably. Right? The farther we expand out, the more complicated the journey is going to be to get to these places. Oh, this is a great factory. This is a nice factory. Buttery, delicious peanuts. Oh, these are so good. I don't even... They're just like... These perfect little pods. You know? You pull them out and you kind of rub the little skins off. And look, they're so creamy. It's so sweet looking. That's wonderful, you know? Probably screwing my mouse though. Stop eating over my hardware. Oh boy, I started the computer up today, chat, and my standing desk wouldn't go up and down. Not a good sign. I was concerned. Eventually it just kind of started working, but I don't know about that. Like what, was a capacitor charging while I was pressing the button? Maybe. I've had a habit of turning it on and off, and I'm wondering if that's just damaging the circuit. So we came here to produce another bite-sized factory, a brand new oil and plastic generation loop. Something closed loop that uses diluted fuel. We want to just minimize energy usage in this modern principle. So, anytime we could, I'm going to create simpler factories with more steps. More intermediates. Oh, I broke a nail, chat. I gotta get some nail clippers for this. Oh, it's just too tasty. For heaven's sake. Oh. This new bite-sized factory will be right next to the existing petroleum coke plant. Right here. Where we're kind of bringing oil up. You're going to need a fair bit of water for the processing. Yeah, let's run that plant right here. I hate to run it adjacent to aluminum, because aluminum doesn't strictly need these inputs. But we do need a water source out of there. Why not project forward here? Off to the left by exactly 3 units. We'll leave one factory space in between. Let's grab a 5x5 foundation blueprint and make sure we are in blueprint mode. And we'll just kind of drop a placeholder. I think if we start on this blueprint, it'll understand what we're saying. Yeah, interesting. It didn't fully understand that. Okay, here we go. 1, 2, 3. Oh, excuse me. Okay, 1, 2, 3 would be a full factory's width. I can see how another 3 is going to be really challenging to squeeze in here. Actually, we just don't have the space currently. This is a place where a vertical factory I would normally consider, but I'm actually saving the vertical factory space for additional aluminum output. I want to breathe more space into this factory, not less. So let's just take a space from the water and take a perpendicular direction from another side. It's okay if water has to travel in a slightly less expected direction. For example, now I'm just going to work with that piece of foundation to find the right location here. But imagine we shoot our factory back in that direction. And we extract water from here. Ad nauseum as well for expansion. Yeah, I believe this is correct. We don't want to interfere with any factories that do project in this direction. Yeah, we're not going to reserve this space for a factory next to aluminum. A factory next to aluminum could start way over here. This is a free intermediate space. We should reserve it. And that allows us to protect for our foundation. Okay, yeah, this is coming together. I can see where this is coming. We kind of want to run parallel to the petroleum coke factory. Only for organizational reasons, though. I know what these plastic rubber factories look like. They need water, tons of water. So we're just, wherever these factories start, they should have a tiptoe over here on the water. Like here. Yeah, they could be here, for example. Shooting in this direction with water starting here. Let's do that. 1, 2, 3, 4, 5, 6. But going backwards, not forwards. Holstering. Nope. End. Man, I'm never going to remember that end. And home is not currently bound to anything. Bolstering. Alright, let's add 3 more 5x5 frames. 5x5 foundations here. 1, 2, 1, 2, 3 as kind of the energy, but we go higher than this. So let's pull up a pillar. You only need a small metal pillar here, but just make sure we're right in the middle of this 5x5. There we go. You can see right away by switching to foundation mode and going to delete, you'll see where the middle of these blueprints are located. I'm just going to zoop this up until we get above the threshold of this. Looks like we might be engaging in a fight here. Cool. Wow, that ammo is so effective. Sheesh. Whoa, what's in the balls? Whoa, sounds like a Mercer sphere to me.
When will you land? Play. Play.
What's happening?
Witness. Harmonize with us. Harvest.
Where'd it go? Where'd it go? Is it underneath us?
Defile the scripture.
There we go, it's right there.
Consume.
Wow, is that expected in the game? We'll just grab items that are like buried and clipping underneath? I mean, I heard it, that's what drove us there. She speaks to you. Anyway, 14 Mercer spheres, congrats, only 9 more. See Mercer spheres chat? No, not immediately. As I said, yeah, we'll be building some new bite-sized factories here. Yeah, it's kind of a crappy angle to take, but it does align well with factory improvement. Let's appreciate it and work with it. And production can be packed over here. Or over here, truly. No, I think we have every good reason to start over here. Kind of hard to pick it, but it also doesn't really matter. Just want to make sure we have access to the water we were promised. Yep, and we'll bring it right back. Foundation 5x5. And there we go. And this would be the spine. One, two, three. 1, 2, 3. Yeah, that's why. That's legit it. Alright, and this is where we can drop 2 of our blueprints. Just letting him know. Pockets of hog meat here. Probably knocking themselves out. Okay. Looks good to me. We'll just drop the blueprint. Nice. Okay, that looks good. Let's head to the front of the blueprint designer, and we'll bring in our first design. Get that 5x5 foundation to start. And this is a little bit of an unusual factory, but I think we'll appreciate it. I'll just pull up my design. We bring heavy oil, we bring crude in and produce heavy oil residue. Number 1. This is the front? Yep. So start with a refinery. And say that the front of the blueprint designer here is where all the inputs come. That's heavy oil residue. Now, heavy oil residue then goes into diluted fuel, and residual rubber takes the polymers. So, diluted fuel in the blender. Residual rubber takes the outputs, right? Okay. Which also requires water. Then you've got recycled plastic going into recycled rubber. And recycled plastic's primary output is to go to recycled rubber. Recycled plastic requires... Let's flip that one around. Yeah, it requires fuel from the blender, and it requires rubber. These factories, you start them with something so that you get them rolling, so to speak. Like if we're producing rubber, or if you're producing plastic, then you seed it with rubber, because the rubber gets turned into plastics. That's how that works. Right? And then the last refinery here is... That's... yeah. Let's just simplify this and do a design for... That's correct, but let's do a design for, yeah. Just plastic to start. Yeah, what about the plastics here? So it still has the same loop. Good, that's what we need. And we use diluted fuel from the blender. And there's residuals from the refinery. Yeah. And you put crude and water in. And the crude doesn't even need any water. That heavy oil residue goes into the diluted fuel. That fuel kickstarts the production of rubber, and it kickstarts the production of rubber via fuel. So there's double rubber production, and the rubber all goes into recycled plastic, where you put rubber and fuel together to get plastic, right? And then you extract the plastics. The overflow. You extract the overflow from the plastics, but the primary is to force the cycle until all the recycling is complete. Yes, that's right. You don't want these machines to just choke randomly. This is kind of complicated, but if you've ever built the recycled plastic loop before, you'll know what's happening here. And if not, Godspeed. Oops. Okay, I'm pretty happy with this representation. Yeah, the loop back and forth, and the part that we extract here. Let's get a screenshot for this. And I'm going to call this recycled plastic. Are these decent ratios, in fact? 1 blender, 1 refinery, 2 refinery, 3 refinery. Oh no, this needs like 5 refineries. That's way too many. I mean, you could squeeze them in. The minimum number of refineries is 4. And we should go with that, right? We should always go with the minimum. And then however the blender gets used, the less the better, right? Yeah. Yeah. How many blenders can you fit on a Mark II blueprint? You know? How many blenders? Just asking for a friend. We're missing aluminum casing. But the answer is clearly 2. So we can do 2 blenders for these 4 refineries, that's the dream. I actually don't know that these blenders will fit with the refineries above them, right? Also, how are we missing casing? I thought that's on the factory. Hold on. Or is casing just something we make by hand? I think we loosely automated casing, didn't we? Wait, no, it's just made in a constructor. Directly out of aluminum. Hold on, then where is it? We made all clad. Did we just not do casing? That's aluminum. Let's check the to-do list. Hold on a sec. I thought maybe we did. The loose automation. Yeah, we have some aluminum casing loosely automated. And I'm sure that's at home, right? Because it needed so many weird recipes. Nah, my dudes. Straight up aluminum ingots. Yeah, the outclad looks great. Two bite-sized factories. Yeah, I'm surprised casing isn't here. Like, if we would have loosely automated casing, wouldn't it be here? That's the oil blueprints. I think we need a bite-sized factory for it. Where did we loosely automate this? Is this back at home? Yeah. I'm checking the map. I'm no joke. Where did we do this? Legit. Aluminum casings, no joke. And what's the input? It was just aluminum. Not necessary, right? And we should be able to get that dimensional depot back for this, yeah. Right, so let's do aluminum casing. We need it to build the structures we use to build the factory itself. This isn't a choice. It is our destiny. So good. And the default recipe is the good one here. It's totally fine. So, we bless it. And it is better to make the casings and ship the casings than aluminum. Casings are... Casings are denser by about 30%, 20%. I think you get 84 casings for 120 aluminum, off the top of my head. Oh. Alright, let me get the nail trimmers here, chap. Alright, a couple more blueprint designers. This time for the aluminum casing. What's wrong here? Okay. There we go, and we'll just have these facing here. And one more facing here. Oh, it's not quite, doesn't quite fit. There we go. Great. Let's start with our 5x5 blueprint. As we do with all our bite-sized factories. And then begin building out that basic shape. And we're going to scale back that whole operation. We're going to scale back to one recycled plastic refinery. So 2.099. Let me just get that scaling calculated. 100 divided by 2.1. $47.6 for whatever reason. There we go. Oh yeah, those are ratios we can really get behind. Here we go. Let's actually save over our existing plan. It's great to have these pre-calculated efficiencies because now we can reduce the output of the energy. It's amazing. And it is certainly scaled to... well, we could scale the whole thing back by half, you know? That's allowed. But it's scaled to maximize on the usage of the one refinery, which to me is like kind of a... It's a way to acknowledge and concede the standard level of difficulty in the game. As opposed to just always evading every level. Just take a screenshot on this. Yeah, recycled plastic. 47.6 out, and the inputs are 15 crude in. And 52 water, so it's so much water, right? It's like 53 water. Yeah, 4 refineries, and we'll utilize 2 blenders, which each will be at 21% capacity. Sick. Yes, very good, chat, very good. And I think we have a good location for this factory as well. But before we get to this, let's do our aluminum casing. I'm glad we closed that door. We'll be back for the oil factory for sure. But for now, we do need just some basic aluminum casing, which I believe it's just made in a constructor. Is that right? Aluminum casing, yeah. pure aluminum ingots. It's just assemblers, yeah. So we could do 2 floors of assemblers and have, I think you can do 4 and you can do 16 assemblers in one, right? Here, try to see how many assemblers I can squeeze into this. Into this 2 floor. Absolutely, look at this. Look, you can quickly see that 1. And then the opposing side. This is where it's most challenging to get the space, right? But then the opposing side, no problem. I believe. Is this too tight? Here, watch, I'll go 1 more. There we go. The tough part is merging the goods, right? Imagine that this is the setup. So you have 8 assemblers on 1 floor. And on this side, you're distributing the goods. But on the outside, you have to round them up and merge them. Is there space for a merger out here? There absolutely is space. Isn't there? Is there space? Look. If I can squeeze a belt into this, there's space. There's space. Is there space here? There's totally space here, I can tell. It's assemblers, but it only requires 1 input, is that right? Constructor. Sorry, it's not even assemblers. Casing is the constructor. But so many constructors here. Alternate all-clad casing. Oh, alternate all-clad casing. And that's in the assembler. My mistake. So, wait, do we not have all-clad casing? That's the problem. There's another recipe for all-clad casing. Ah! So what's so good about all-clad casing? Tell me the merits of all-clad casing. They're similar. They're absolutely similar. Yeah, the default recipe is good enough. The default recipe is good enough. Such strong options and no real difference here, though. Such trash. No, dudes, we're not hurting ourselves, like... We'll go with the default. Literally, we'll go... It's completely fine to go with the default. So it's all constructors, and we're just doing aluminum. Nothing fancy. And how many constructors? Who's that down there? Wait a minute. Who's a buddy? Who's a buddy? Oh, it's Chizerjago, and he's got some steel pipes for some reason. Well, thanks for being a buddy. Good luck, buddy friend. Good luck. Find some more pipes. Constructors? I'm pretty sure we can do 3 floors of constructors, is the truth. We've never been challenged to pack such a blueprint with constructors, but imagine that this is the front of the blueprint and we're bringing the goods in. We'll pack it in so tight. Okay, let's start with a merger. Or a splitter, excuse me. And the limit here is maybe this. Yep, totes. Yeah, that's pretty good though, eh? 2. 3, 4, 5. Here's the thing, we'll bring the input directly into 1, split it, and then we'll split it out again, right? Right around the right. And then we'll pull the same nonsense, except we'll merge into this direction. So mergers appear on the other side. And we draw the goods back the other direction. This way. They can be right on top. Yeah, they can be right on top. I'm not gonna do that. This is already gonna be so efficient. Yeah, we'll make it 1 off here. 2, 3, 4, 5. And now you can do a second floor of these. Can I just call this a blueprint and then I can make floors of this? Would that actually work? That'd be crazy. That'd be crazy. That'd be crazy. They need to be moved back just a little bit in order to accommodate another split to go to the back. It's a little complicated to design this factory if you want 5 constructors in a row. And if you had an extra space here, you could jump the belt forward. Yeah, you need a belt width here. Yeah, imagine this. Or let's just delete this. Hold on. The wonderful thing about this is you can just clear blueprint designers, and then right away load that 5x5 again. So easy. No deleting. Unlimited experimentation. More than anything, we're playing with the positioning of the splitter here. So let's see how greedy we can be with the lift. It's basically that. Does that emulate the same as the splitter? Yeah, probably. 1, 2. No, that doesn't fit, but does the belt fit? No, the belt also exceeds, so it's got to be 3, right? 1, 2, 3. And now we can fit it, yeah. Alright, I'm willing to accept this. Yeah, we throw splitters coming in from the right. Sure. This one can come in from the middle. That's all the inputs. Constructor for each. And since we can be so close, we do be so close, right? This puts us literally on like 2 squares, which is just nothing. We got that one backwards. One, 2, 3, 4, 5. Okay, this is looking really tight. That's nice. Yeah, and you know these will connect, right? What's the throughput here on this factory? Let me just check there are casings. Pretty much 1 to 1. No, it's 3 to 2. So, however many we're willing to put out, honestly. One constructor somehow does 90 aluminum a minute. So one of these factories has the capacity to do a crazy amount. Whoa. We'll slow those constructors right the heck down. And let's just find the belt limits, right? We'll just max it to the belt. We'll see how many constructors we fit, and then we'll scale it to that, right? Yeah. I'm pretty sure we're going to get 3 floors of constructors here. Which is 30 constructors in total. That's crazy, dudes. Alright, let's try it out though, yeah. And if we did have 30, and we had max belts with a 240 limit, then we could just take the 240 and divide it over 30 and take that efficiency. Or tailor it to 480, it's totally your choice. Alright, let's merge these back. Oh, shite. Get this crap out of my inventory. Mark 5. Let's fix this assignment here. Let's just do splitters and mergers. Splitters and, yeah, splitters, mergers. Foundations. Pillars. We can do pretty much anything with this belt. Especially this, because we can switch Mark tiers of belt, right? Dude, Mark 1 belt is going to be more than sufficient for this operation. Like 60? If there's 10 here and we had 60, that'd be 600 we can handle with Mark 1 belts, right? And the output's even lower than the inputs? Yes, correct. Let's get back to our Mark 1 belts. Let's do Mark 5 belts between these. I would probably do Mark 4 belts on the insides here as well, but just depends on how you want to scale this factory up. It could handle a high disposal. Yeah, let's say this is the main input. Every machine gets an input here. Yep, and this input skews right over here. Bam, done. That's all it needs. It needs a circle. That takes care of the inputs on this side. Oh, except for this one. There we go. And let's get Excellent. And outputs. Nice. Inputs and outputs. Okay. This is going to be a fun little calculation, yeah. And I just want to make sure that we can get 3 levels worth. I think we can. One, two, three. I think we can, yeah. And we already have a place to join the layers to merge the outputs. We can tune these however we like, yeah. But we'll clearly tune them to a maximum belt output. Mark 5. We don't have to shoot for the maximum. We could shoot for a factory that does like 100. You know, a reasonable amount. Or a factory that does like 300. Just like an arbitrary reasonable input. Like imagine you could handle having 4 of these little blueprints, right? That's no big deal. Sheesh, peanuts again. Sheesh, peanuts again. Can't help myself. Can't help myself. Love the peanuts and nobody else. So I think we're just printing 3 layers of this. We can call this 10 constructors on a layer. Like, why don't we, let's give it electricity. Mm-hmm. Right, and here's the input, and there's the output. I'm just going to save this. It's not quite a bite-sized factory. It's more like a bite-sized component. A nibble. More like a nibble. These are like 10... It's 10 constructors. Oh. What if we had a pillar we were placing these on? Okay, here we go. We can drop a pillar here that allows us to get to the center. And how many soups can we afford? It's 2, right? Yeah, what can we accomplish here? I think I'm just putting this here, and then I'm dropping a pillar underneath. And then the pillar is the placeholder. And then I can drop these. And hopefully our bite size, our nibble, will fit right on top. Okay, yeah, that's actually working. Is that simply working? Look at that, that's a second layer. Totally constructors. It worked. It straight up worked, yeah. So you would configure a layer, save it, and then layer it again, right? That's wild. Yeah, and the input here, oh wow, this is amazing. I gotta say, that's absolutely like kind of mind-boggling. I'm gonna run so many constructors. I'm gonna run so many constructors. Like 10 constructors per level, and I'm gonna do 4 levels. I can do 4 levels. Do you see this? I can do straight up 4 levels. There's only 2. We're gonna have 40 constructors in a single block, constructing away at a very slow rate. It's almost not worth configuring. No, it is. You only really have to configure the nibble, the 10 of them. Hooking the 4 layers up is certainly a chore as well. Maybe I'm biting off more than I can chew, but it's still a blueprint. I can't wait. So let's do a little bit of math. Not math. Math. Let's do a little bit of mathematics. The way I see it, we are not making this. We are not making all-clad casing, and we are absolutely giving it aluminum. Aluminum. Let's say that we want to give it 240 aluminum ingots. And we want to to maximize. But there's no bauxite, and there's no SAM. Nice, there you go. There's the answer. $240 aluminum ingots. Uses 2.667 constructors. So we're splitting 266% across 40 machines, right? That's how that works. So you get 6.65% per machine. And then if you add all those up, you'll get 266. Right? You guys picking up what I'm laying down here? It's the total constructor efficiency related to the aluminum ingot input and casing output. So my machine will do the same thing that this machine does. But my machine will utilize 40 constructors instead of 2.667. So you can think of it as spreading out the work of 2.667 constructors across 40. Yeah, which gives you 6.66%. 6.66%. Okay, that's totally consistent. Sorry. 2.66, yeah, so 6.66%. Yeah, I like to think of these as hundreds as percentages. That's why I'm like 266.7. It's like, yeah, 6.6675% or 6.67%. Per machine if we get 40, and I believe we're getting 40, so let's absolutely rock into coding these machines for their recipes. Casing, please. Aluminum casing, done. And the clock speed, 6.67. Giving you 4 per minute. 4.002 per minute. Am I allowed to specify 667? That's right, 4 per minute. Dude, we're allowed. We're totally allowed. It's just not even going to require any power at all to run. It's the truth. Production, paste. Production, paste. Production, paste. We love coding machines. Production, paste. Production, paste. Production, paste. Production, paste. Perfect. Now you can save this as a nibble. called the nibble for aluminum casing. 6.67% times 40 constructors. It gives a specification of 240, but if you divide that by 4, you get 60. So the real specification there is 60. It's 60 aluminum ingots in. There we go. Kind of complicated, but it's mathematically consistent. Oh, you can place this right in the middle. I bet. Okay, let's do our best here and replicate with the nibble. The back is indeed there. Bam. And can we do another one? Yeah. The back. And I assume we can do one more. Partially overlapping the blueprint designer. Nope. Okay, that's the mega church upon which I built my house. Do you see this insanity that I've crafted? These work. These are all wired to 6.67%, meaning that their target power is going to be ridiculously low. And this is how we will make aluminum casing. This is how you optimize one recipe in a whole Mark II frame. It's wild, yeah. Okay, so let's just connect the outputs and inputs here a bit. Let's go bottom to top. Okay. Inputs come in. Great. Let's find a splitter. Oh no, this splitter's perfectly cromulent already. So let's just split this here. And you can split it from the bottom here to go to the third floor. And then you can split the second floor to go to the fourth floor. This works. Trust me, this works. We've tried. Okay, we're just gonna get rid of these more formal inputs. And utilize the highest capacity belt to run the transfer between. There it is. There it is. Boop. That's your input. That's your input. And that's your input. Alright, everyone's got inputs now. Dum bum bum. Where's the music? No. I didn't catch it. Okay, and so this is outputs. And this is outputs. And this is outputs. Let's go top to bottom. 8. So this output I think this is actually going to work. We're trying to lace this in. It does work. Literally. So the top floor pulls into the third floor. Got it. Third floor pulls into the second floor. This is a work of art. This is my Michelangelo. You know? I'm gonna carve a huge pair of genitals on the outside of the factory. That was always the case. Here we go. And then all of the floors pool into the bottom. Wild. A lot of Mark V belt in this piece. It can do a lot. Ooh, excuse me. It can do a lot. This is a masterpiece. Okay, we need to connect the power as well. Here they are. 2 to 4. 3 to 4. 3 to floor. There you go. That's it. Did we select casing as the recipe? I damn well hope so. Yes, absolutely. And is that the fastest possible belt we could even have? Yeah, it totally is. Let's save this as a bite-sized factory. For aluminum casing, default. To which I will say it is 40 constructors operating at 6.6 per 7%. Equals 240 aluminum ingots. And I think we're doing 160. Yeah, 160 casing. It's just aluminum ingots. This didn't necessarily warrant a factory, is what I'm hearing. We could have just slid this out and moved on with our lives. Yeah, whatever though. What the heck is that stuff way over there? Is that a tree? Looks like a portal or something weird. It's weird. It's weird, chat. I don't know what that is. I don't trust it. Let's place this factory now. I believe we will need only one of these. So we can even tuck it right here. You know. We can do a little 5x5. Yep. 5x5 foundation on blueprint mode. Nice. This wants a 5x5 confirmed. And here's a perfect place for that factory. If we need to get serious about casing, we will. Aluminum in, casing out. There it is. There it is. Yes, in all its power. What a factory. It's still connecting. There. It finished. That's crazy. Okay, and does it read the power correctly? No, it does not. It needs power to run it. We will provide that. How about now? They do not. They do need to be running. Okay, how about some aluminum? There's a splitter there. Let's get ourselves another splitter here. Oh, dang, this is looking real fine. Real damn fine. Alright, there we go. Boom. Okay, some of these don't have power or recipes. It's the nightmare, of course. But they're damn close. Oh, I love this. God, I love this. But it's real slow, right? Like the refractory period here is so slow. And what's the power consumption? 0.1 megawatts out of 4. That's 1/40th. A 40th of the energy usage. It's crazy, dudes. Wait a minute, is it exactly a 40th? So what's 40 times 0.1? The entire array uses 4 megawatts. But we can produce 240. So it uses the same as 2.6 constructors? No, it uses the same as 1 constructor. It uses the energy of 1 constructor to do the work of 2.6, right? The energy of 1 constructor of 4 megawatts to do the work of 2.6. Right? Yeah. You hear what I'm saying, right? 2.67 constructors normally, that's how you get 160, but we're doing it with the energy from 1. So it's a 67% energy savings. Excellent. Not necessary, though, but an interesting proof of concept, for sure. Okay, and where were my errors? One here. No power. Yeah, no power, and it's hard to find any. But if you can find a systematic answer, it always works in this factory. There's a 3. Got it. Nice. And you can do that on every floor. In fact, you have to. Just to make it work. It's a fun house of aluminum ingots turning into casing. It's an absolute joyous occasion. What a joy this is. It's one of the funnest things I've ever built. I gotta say, yeah, something about this is really rubbing me the right way. Yeah, it's good. It's good. Very good. Very good. Yeah. That's pretty rare to get ingots on top. Plus, this factory holds a huge amount of aluminum in storage. Yeah. We could develop the mathematical model for the energy savings. Okay, that's casing. Great job. Let's get a little storage. And a dimensional depot. Oh, it needs SAM fluctuators. You guys be mad. You're gonna be mad. I know what you said. I shouldn't be dinging. SAM fluctuators though, there's no... We don't even have a temporary place for that. And what is it, wire? It could just be an iron. It's just iron and... Yeah, there's no excuse for this anymore. Pure iron SAM fluctuators, that's reasonable. Truth is, I have a ton of these already crafted by hand. Right. And caterium circuits are optimal. Let's just address the title of the stream. They're totally optimal. They're amazing. We're going for them. Okay, let's play. Let's play. Shh, hide that crafting bench. Alright, that's casing. Literally every single constructor, except for these 5 on top, is running. It's amazing. Okay. That answers the casing issue for factory construction. So we should be able to build blenders now? Was that the issue? Yeah. Hmm. And I just wanted to see how many blenders I could fit. Kind of looks like 2. Let's also take our accolades here. We did aluminum casing automation by SATISFACTOry. And that's done. And we found caterium and copper near the oil and water. I think we have an answer for that. Let's check that off as well. And we checked for water access. That was correct. It did work. Now we're working on a rubber and plastics factory. As part of the caterium computers. Yeah, 'cause it's actually pretty straightforward. And we have most of the goods. We have all of the resource nodes we need. That is some hell-ass damn, I'll say. Can you fit 4 blenders in? What if there's little consideration for the output? Just minimal. I don't know if 4 is enough. But I think that does. You only get 2 on this side, I see. It doesn't fit. How do we do that then? How do we get 2 refineries? There's a little extra space here as well. So how much space does this thing need? Oh, quite a bit. Look, wouldn't be such a big deal if refineries were on the bottom. Let's see what we can construct. Let's just clear the blueprint designer. Try this from scratch. Just remember, trying to construct, no, not this. We're trying to construct... Nice. Let's see if I can get the image. Yeah, this. The recycled plastics. And we have 1 refinery. There's 4 refineries. I know this, yeah, there's 4 refineries. Watch and learn, ladies. It's important that the pipe is at the front so that we create as much space as possible for the blueprint designer to clear the blenders on top. One. I think this is going to work. 1, 2, 3. And recycled plastic is the final output. And it's the overflow from recycled plastic that we get. Yeah, which is why it can have the same alignment as all the other machines. That's totally fine. Nice. Let's throw that pillar down and find our second floor. Okay, this super matters as well. Is this good enough? We're going to be real picky about the placement here. Did we not get this in the center? We did. Yeah, no, I don't know about that. Can we get a blender up here? No. Oh my gosh. By like an inch as well, if I may say so. So we just need to pull this down just a hair. Which we can do. There seems to be utterly space, right? There we go. Okay, that's the new standard, and that allows us to do 1, 4. Now, how many blenders can we get? Okay, we are clearing blender. We are absolutely clearing blender. We're absolutely clearing 2 blenders. That's wild. That's literally what we need. There it is. 4 refineries, 2 blenders. Gorgeous. Yeah, it's a gorgeous 2-level factory here. And these blenders make diluted fuel, but each would normally only run at 42% efficiency. What do we have here? Yes, each one would normally run at 42% efficiency, and that's with recycled plastic running at 100% in its refinery. We can scale this back in any way, but we're just going to scale it to 100% of recycled plastic. Like, we're allowed to scale that arbitrarily down by any factor here. If we want, we can cut everything by 2 if you want. I don't think they want that. Well, maybe we do. These are pretty expensive items. I'm not joking, these are pretty expensive items. And we're gonna run one of the refineries at full time whenever we need plastics. And so much water per minute is needed. Yeah, it's like 60 water per minute. So you'll get 10 of these factories per pipe. So 5 along a spine. And then you'll need a new water pipe. That's actually an okay density. And it would be okay to cut in half. Then every length of 10 on the spine or every 20 factories, you'd need a new water input. I'm ambivalent. It's just buildings to me, right? They're costly. How much power do we save? What's the equation, you know? Here's your answer, chat. Your production will remain the same if you double your buildings, but your power usage will be reduced by 20%. And here's the equation. Power usage equals initial, so there's this factor of clock speed over 100 to the power 1.32. Not sure what I'm looking at exactly. The exponent is log base 2 of 2.5 rounded down, meaning you need 2.5 times more power to double your productivity. This applies at any clock speed. That was my calculation as well. That worked on the last factory as well. So if we had, let me just grab a calculator here. If we had an initial energy usage of 4 megawatts, but we put it at 6.67 divided by 100, so 0.0667 to the power of x to the y. No, I need a real calculator. 0.667 to the power of, what was that, 1.3 whatever? 1.321928, 1.321928. There it is, 58% of the original. And what did I calculate? I was doing the work of 2.667 in 1. So 1 divided by 2.667, I thought. One minus, is this the ratio I was thinking of? Yeah, there's 59%. Yeah, you get this 0.58 factor, so you get like a 40% savings. That was my calculation. Yeah, and your gains are like 20%, so it's not that big a deal. Like, you could just do 3 constructors instead of 40 and not save the 30%, right? Like, it's a little bit, it's a little bit, We're not busting ourselves, that's for sure. Like, if there's space, there's space, but if there's not, there's not. You fill the space, that's to be sure. And here's the truth. Here's the best gain for one more building. Adding a second building and clocking 50%. Yeah, but if you already had 3 buildings running, getting 6 will save 20%. 6 was the best. Yeah. If you had 3, getting 6 was the best then. This is a principle we can save. This is somewhat fundamental. Okay, we were talking about that corollary. Okay, yeah. Here, let's speak frankly about it then. Power usage decreases exponentially with the number of buildings. Corollary power optimization. But there's a limit to it. Clock speed 50%. Times 2 buildings. That gets you 20% power save. This is best gain for one more building. There we go. Yeah, that's a more clear statement of that principle. And it's you can go arbitrarily with the power savings, but you get such diminishing returns on the number of buildings because it's just so many buildings. But when you add 1 or 2, you get such fantastic returns. 20% savings, 30% savings. It's a big deal. It's kind of a big deal. Yeah, we're doing plastics right now. Good work, chat. Yeah, it's complicated, but we got it. And here's 2 blenders, both making diluted fuel. Let's get that blueprint. Okay, crude oil. Let's say crude comes into the first one. That makes heavy oil residue. The polymers they go into the residual rubber factory. Residual rubber. Got it. And the heavy oil residue, it's going to go upstairs to the blenders. Let's just make sure there's enough head lift to get this thing up. Nice. We're only going to have 10 polymer resin here in a minute, so let's we don't have to bust ourselves into it, but goes to the residual rubber factory. Okay, yeah, so all of the poly goes into this second refinery. Right? Good. And it also gets a source of water. And the diluted fuel also gets a source of water. A little close to the edge here. Let's get a splitter. And now that's water. Nice. Make sure there's a little head pump. power up all of these machines. Cool. Okay, let's finish that trace. We have that the heavy oil residue produced goes up to the blenders. The blenders get water with the heavy oil residue, and that produces fuel, which goes into 2 locations. Yes, it's going to 2 locations. It's going to recycled plastic and recycled rubber. Not residual rubber, recycled rubber. So there's recycled rubber, recycled plastic at the end. And the diluted fuel goes to that recycled rubber factory. So let's get all that diluted fuel together. This is recycled rubber. Yeah, so if you see 0.5 efficiencies in these diagrams, it means that we're emulating that use 2 machines as a replacement for 1 philosophy. So generally that's a 20% energy savings when you see that. And it scales up to 30% with a ton more, but 20 is the real savings. Okay, some of that fuel goes into the recycled rubber, and some of that fuel goes into recycled plastic. Yeah, and you start this factory with a ton of rubber and recycled rubber, I'm pretty sure. Let me just get rubber here. And you just put a ton of rubber into this machine to start. Oh, you put plastic into this. This is a plastic factory. So I put that in the recycled plastic machine. Ugh, my goodness. Here we go, recycled plastic. And then I preload recycled plastic with rubber so that it produces as much plastic as possible, much of which goes into recycled rubber. The These can be pretty close, right? I think we can get a better angle on that. Nice, and some of the fuel into recycled plastic. These are all inputs at the front, yeah. Easy to understand. So that's both sources of fuel. So blenders are connected. Now the recycled rubber receives the fuel and it outputs rubber that it pushes into recycled plastic. So it outputs rubber that it pushes into plastic. Done. And that's all. And this thing outputs plastic that it pushes into rubber. All right. Let's just get a merger here. It's not going to have outputs that go back into itself. I'm trying to push the plastic outputs into the input of rubber. Okay, it doesn't have any merging yet. Yeah, let's just try that. So the plastic outputs into the input of rubber. There, the snake eats its own tail. Check. And so that's all inputs and outputs. It's got two inputs, it's got the one plastic output. And the other output is its overflow. So we need a smart splitter. And only overflows come out. That's how this works. And to configure this, you want right to be overflow and left to be any. And forward doesn't matter. Great, so that's the peel off. And residual rubber pushes rubber. This isn't quite right, yeah. Oh no, that is correct. I just need another merger. Okay, how about over here? This is where those goods go. Good. And the rubber from residual rubbers. Yes, residual rubbers will also generate plastics. There we go. All the resin goes to generate rubber, which makes plastics. The plastics... Wait a minute. The plastics come out of here. We got the outputs backwards. Yeah, the plastics come out of this refinery. Yeah, the plastics come out, and then when they overflow here, that's when they're outputs. So it's actually here. Perfect. It's the same philosophy, just the wrong machine. Okay, and here's the splitter. Goods come in. They go into that machine by default. Or they come out here. There we go. Yeah, sheesh. Oh, it's supposed to be a smart splitter, excuse me. Ugh. So annoying. So annoying. Okay, smart splitter, excuse me. That's correct. Excellent. And configuring the smart splitter. Left output is overflow, and the right output is any. Any. Excellent. That's the whole enchilada. And you preload plastics with rubber. Check. And that gets fuel running. And for our setup, the efficiency on diluted fuel would normally be 43%, but we're cutting it in two because we have two of these, so 22%. So that's pretty efficient. Blenders are so expensive, so cutting 20% off their cost is huge. Yeah, we had like a 60% energy savings, right? Yeah. 60% energy savings is huge, right? You can double the size of your factory. Well, it'll certainly be more than double the size because you'll be saving 60% energy by increasing its size. But I mean, you'll be able to double its throughput per unit energy. Such a beautifully designed game as well. Alright, so the first refinery here, just going to tune these up. That's heavy oil residue running at 53%. Nice. Next machine here is... You get the blenders. Recycled rubber. No, residual rubber. That's 27%. I should be producing 5.3. Yeah, it makes 5.4 per minute. That's amazing, yeah. These calculators are so convenient. Okay, and the recycled rubber, not residual rubber, but recycled rubber, that's at 42%. And the recycled plastic's running at 100 all the time. I'm calling that a day. That's it. Inputs and outputs. Plastic. We just call it plastic. We wouldn't do anything else. And we'll give some numbers on this. It's 16 crude and 53 water to make 48 plastic. A nice plastic icon. One of the best icons in the game, this stack of plastic. Looks delightful. Done. Is that an expensive factory? It's got to be a fair bit of alclad there, right? No. Wow, that is a cheap factory. One AI limiter for the smart splitter. 20 computers for some reason. Don't know what those are for. Blenders, I guess. And the input on this is very simple. This is just oil in, plastic out. Water in. Oil and water in, plastic out. Oil and water, plastic out. Let's drop that blueprint. We didn't put one down yet, did we? No. Blueprint design Mark II. Power pole's nice to have on these. There we go. Let's label that. It's our bite-sized factory. Plastic spot. And we'll choose the secondary color. Beautiful. Alright, let's process some of these oils right up here. One, two, three, 1, 2, 3, and this is the spine, right? Yeah, this is the spine right here. It's always a little tricky to decide where to start. But I think this was a fine direction for the spine. And I needed the spine to start back here or farther. Here was good though. There we go. Okay, that's the spine. Let's absolutely drop the standard blueprint. Arrow facing towards us. Grab some power. Nice. Sick, that's the full thing. Okay. Show me some crude. Show me some crud. Let's just run this over here. Okay, here we go. 5 water extractors. 1. Okay, let's go. So this thing makes crude, heavy oil residue, polymers. Polymers flow out. They become part of this ecosystem. This produces rubber with plastic. This needs fuel. Very good, slow and steady making that fuel. So we're spending 20 megawatts. Good. Okay, we got some fuel. Let's go. These factories always seem like magic to me. But what I know is that this thing has to keep producing rubber or plastics until eventually it has overflow. And one thing's for sure, it's always going to have backing. It's always going to have rubber, because rubber's the priority of production, and then we just skim plastic off the top. Good, that's how it works. We did good. I think that's it. We're just waiting here. Takes a long time for these pipes to fill. Yeah, that's the case. But we're letting it happen, yep. It's a beautiful factory. There we go. Fuel out. Plastics producing. And we should see some plastics pop into the rubber factory here. Yep, there we go. There we go. Plastics popping into the rubber factory. Good. Okay, it's working. I think we've got enough fuel. Everything is running 100%. Let's go. Beautiful. Okay. Let that happen. I think we're going to get overflow plastics any minute. I guess we won't any minute. It's like this has to overflow with plastic, right? Yeah. Well, it totally is overflowing. It's working. I mean, it's not overflowing, but it's producing and it's starting to... It's filling. Yeah, there's an excess, is all I mean to say. And what is this? 16 crude per minute? Oh, man, it's like nothing. Gosh, you really want these oil and rubber factories lower down, I'll be real. Piping this all the way up, that was a pain in the butt. Okay, let's implement this in a larger scale now that it's absolutely working. What a brilliant, beautiful, luscious, smooth, dreamy, plasticky night of the dead. Here we have rubber, plastic. Five was the answer to how many water pipes? 1, 2, 3, 4, 5. That's 100 times 5 is 500 throughput. 110, yeah. It's like 550. And the plastic factories. Missing motors. Copper sheets, motors, there's a lot of things here. It's a big factory. Big, expensive factory. Maybe I need to ease off the power addition here. Should I be cautious? Yeah, maybe my capacity dipped off as well, I noticed. Yeah, I haven't even connected these factories. And why the sudden rush? 3, 35, 43, 44, 48, 5,000? Who's running? Oh, yeah. Motors, all the other factories, everything that makes things is running now. That's our factory. It fluxes up like 2,000 megawatts to generate more factory. Sheesh. Yeah, well, this is going to be quite a piece, let me tell you. So what's this? 9.5, 5.3 is 15, 25, 28 plus 30. Is 50. 70, so it's 70 megawatts for each one of these factories. So if I did 10, it'd be 700 megawatts. Ah! Okay, just relax, relax, relax. Here, we're just gonna do 4 of them. Okay. 1, 2, 3, 4. No one gets hurt. And seriously, no one gets hurt. Oh, it's on top of the blueprint designer. Whoops. My mistake. That's too bad. Whatever, I'll just put the next one here. These factories are so fun and easy to connect. It's ridiculous. Whee! Every grip, every clip, every poke, every pop. A delight. I guarantee. Better than putting your hand in a toaster. Slightly. Power, please. Should definitely be one refinery on both of these. Yeah, there is. And then soon it'll be blenders. And then eventually it'll be plastics. Yeah, it's happening. Alright, good. All of our plastic machines are working. Okay, easily plastics. And now the same thing holds for rubber. It's a slightly different setup. You don't do recycled plastic, you do recycled rubber at the end. And you preload with plastics. Makes it a little expensive, but preloading with plastics is important to ensure that it runs. And then instead of recycled rubber, you do recycled plastic. At 42%, yeah. And instead of residual rubber, we're doing residual plastics at 27%, I presume. I'm just using the same ratios. And this is alternate heavy residue is correct. And everything else is correct. It's an identical setup. Save it, print it. $16 crude, 53 water is 48 rubber. Rubber. Looks great. And we could run rubber in just the kind of same way. But backwards. Like over here, yeah. Probably not straight, more like if the 5x5 factory started down here. Let's see, we'll pick good locations. Let's just choose a 5x5. Or actually, the full factory will do. And it is a little arbitrary where it lands. We just want to make sure it goes, that it fits into the lake geography. Just kind of... like this. I guess like this. And then we can drop some spines. about here. There we go. Just waiting for that crude. Oh. Nice. Which leaves us an absolute rubber factory. Yeah, rubber chicken factory. I wonder if there's some easy to get Mercer spheres near here. You know what I mean? We're at 13 of 23. If we could just grab 10 Mercer spheres. I don't even know that we need it though. Like, yeah, our upload rate is quite competitive. And we kind of need those Mercer spheres for other goods. Yeah, I know. Yeah, that is true. So we'll grab our plastics and we'll grab our rubbers. And really, we'll just, we'll move them all the way over that train over there. It's a little unfortunate, but it's where the train is. The train do be at. There we go. And where is that train station? I believe it's way over there, isn't it? Over there? Where's the train? Right there. It is that. It is absolutely that. So we could sneak right out over here. Let's update this logistics bar as well. Let's just get a little ramp up here. And then foundations. Yeah, we'll just head all the way to the train. Bozite? Yeah, it must be Bozite. Alright, I think that's actually the destination. Let's get rubber and plastic out of this factory. And off to the rails. Okay, that's a plastics line. Let's do the same thing for rubber. Alright, we'll just, let's get the belt out here a little bit. Oh. Shenanigans. I just want the vertical conveyor belt to be visible. So I'm taking the lower conveyor belt all the way to the edge. A little bit arbitrary where we bring these goods. I think over to the land is going to work best. It's a little bit arbitrary. Yeah, quite arbitrary actually. Okay. 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 Plastics and rubber. It's also totally a choice just to send crude places. You can see that it's a closed loop. All you have to do is add water. Add water to crude and you're generating plastics and rubber in whatever fractions you please. Yeah, and it shows because you spend 47 rubber, or sorry, you get 47 plus plastic out of only 15 crude, so it's very dense, the crude. It's a bit foolish to transport the plastic. Now that we've got this factory, you'd much rather just ship the crude, right? Just so accustomed to having plastic and rubber produced and sent. It's needed in so many places. And why send crude and then also build plastic and rubber when you could just send plastic and rubber? I don't disagree with that, yeah. Throughput is the short answer. Throughput. You want a higher throughput. Wait at least 60 seconds. Alright, the copper is there. See you later, buddy. Bye-bye, buddy. He got off the train there. That's so funny. That's amazing. This game. This game, though. And we will add just a couple freight stations here. And railway resumes. Now the train can load these two goods right from our belts. One plastic. Too steep. Fair enough. That is quite a confusing entity, eh? Plastic and rubber together forever? Nice. Let's just, before we get too invested here, let's absolutely delete one of these. And then add 2 freight cars. And then return the locomotive. Alright, looks good. Now turn on. Alright, cease the loading. Begin the docking procedure. Whew, give me those plastics and rubbers. Alright, and then you can take us out to the copper caterium factory. I think we need to do a stretching routine here, y'all. Getting pretty tight. I just thought maybe we'd get to those radio control units, but it's a lot to automate rubber and plastic. Alright, here we go. Out to a caterium factory. Bringing a truckload of plastics and rubber, produced in the most efficient, balanced, complete way. Wow, there's a Mercer sphere right there. It's kind of nuts, I keep forgetting about that. And on the map, we're basically at the thing. Like, is there water under here we can use? Can we use this? Whoa, yup! Let's grab that Mercer sphere. It's too good to be true. Didn't take? It did take. So, rubber plastic, but where is caterium coming out? It's caterium, rubber, plastic, water, and copper, correct? Yeah, here we go. Well, here it is, just down the lane. Yeah, I guess we need to roll all the way up the coast to get that caterium, right? That's how that works. Yeah. It's just another train stop. Yeah, it's another train stop. We gotta continue. Oh. Oh, shit. Oh, ow. Yikes, trying to get those stretches in, chat. Stretches here. I'm feeling that we need to extend this train that picks up copper. And now it drops off rubber. As well as plastic. I think we should just grab the caterium by train. We're already having to belt so much of the caterium up out of the cave. Yeah, it'd be nice not to pursue harder. A lot is going on here. Wow, yeah, we've really just expanded the crap out of this place. Once we hit the middle of the map, we didn't turn back at all. There was no need. So tonight we got a rubber factory and a plastics factory. A lot of things happening. We didn't get to the caterium computers, but we are darn close. Oh, I see. Yeah, we're not close to the radio control units either. We still need insulated crystal oscillators. I don't think insulated crystal oscillators will be the worst. Heck, we might have those ingredients right here. I saw there was quartz. I have every reason to believe these are easy. We're getting there on the caterium computers. Yeah, let's just add ourselves a little task here. Let's say train to and I just want to extend the existing train. The copper train that's making aluminum possible. Oh, great job, Chad. Let's do ourselves an evening stretch here, shall we? We've got a nice cozy room here. We're ready to do a little cozy stretch. Let's do it. I'm gonna save the factory. Nice. Alright, let's get our little camera set up, shall we?
Welcome to Overcome Pelvic Pain for Men. My name is Michael Hodge. I am an overcomer of pelvic floor dysfunction, as my shirt says. I went through this for 5 years. It was incredibly deep and dark, and I understand what you're going through. One thing that really helped me get a lot of momentum was to start out each morning as totally open and relaxed as possible with a really good stretching routine. And that's what I'm bringing here for you today. This is where we're going to begin. We're going to begin by allowing our body to just feel as it feels, but putting ourselves in position with breath work and stretches, they're going to really open up those muscles. It's going to release the tension, becoming conscious and aware of what's happening. And we're going to be able to go a little bit deeper each time we do this routine. We're going to go and get started. Now, right before we start, I want to point out a couple things that can help you. If you have a towel or a blanket, please get that. A belt would be good, or a strap, a necktie would work, and yoga blocks or pillows of any sort can work. Now, if you don't have any of this stuff, you can still do the whole routine just fine, but these props are going to help you out a little bit as we go through this routine. We're going to get started with some deep breathing. Go ahead and lie down on the floor. What we're going to do actually is put our soles together, soles of our feet, and you can take your yoga blocks. If you would like to, on the higher position, allow your legs to just flop out. And this is a totally relaxed position, opening up the pelvic floor. You can put your yoga blocks this way, pillows, whatever you need to do. Super flexible. Your legs fit, you can flop down lower than that. But as long as the support actually allows you to not have to engage muscles, and you're really just allowing things to be right now. We're going to first do 4 deep breaths. And on these breaths, I want you to breathe in really deep. And imagine the air and the energy really going down into your pelvic floor. So we're breathing and expanding into the pelvic floor on these 4 deep breaths. Ready, along with deep breath. Deeply in. Breathe in. Last one, breathe in. We're going to do some more breaths now that are a little different. I want you to really consciously notice if you're holding tightness in your muscles and allow them to release. So what we're going to do this time is 3-part breathing. We're going to put our hand, I'm going to put my right hand on my stomach, my left hand onto my chest. You're going to breathe deeply into your stomach. Your stomach will rise, and then you're going to breathe, and the air will allow your chest to rise, and your ribs will come up and expand. And then on the out breath, your chest will fall, ribs will come in, and then your stomach will also drop. You don't have to be perfect on this, but I want you to overanalyze it. It's really about a good deep belly breath, and then a reversal of that. And again, allowing everything to just be totally relaxed. We're going to do 8 very deep breaths. Ready. Breathe in. Deeply in. Breathe in. Make sure all the muscles in your body are relaxed. Deeply in. Welcome to Overcome Pelvic Pain for Men. My name is Michael Hodge. I am an overcomer of pelvic floor dysfunction, as my shirt says. I went through this for 5 years. It was incredibly deep and dark, and I understand what you're going through. One thing that really helped me to get a lot of momentum was to start out each morning as totally open and relaxed as possible with a really good stretching routine. And that's what I'm bringing here for you today. This is where we're going to begin. We're going to begin by allowing our body to just fill up the fills, but putting ourselves in position with breath work and stretches that are going to really open up those muscles. It's going to release the tension, becoming conscious and aware of what's happening. And we're going to go a little bit deeper each time we do this routine. We're going to go and get started. Now, right before we start, I want to point out a couple things that can help you. If you have a towel or a blanket, please get that. A belt would be good, or a strap, a necktie would work, and yoga blocks or pillows of any sort can work. Now, if you don't have any of this stuff, you can still do the whole routine just fine, but these props are going to help you out a little bit as we go through this routine. We're going to get started with some deep breathing. Go ahead and lie down onto the floor. What we're going to do actually is put our soles together, soles of our feet, and you can take the yoga blocks if you would like to on the higher position. Allow your legs to just flop out, and this is a totally relaxed position, opening up the pelvic floor. You can put your yoga blocks this way, pillows, whatever you need to. It's super flexible. Your legs could even flop down lower than that, but as long as this support actually allows you to not have to engage muscles, and you're really just allowing things to be right now. We're going to first do 4 deep breaths. And on these breaths, I want you to breathe in really deep and imagine the air and the energy really going down into your pelvic floor. So we're breathing and expanding into the pelvic floor on these 4 deep breaths. Ready? Along with me. Deeply in. Deeply in. Breathe in. Last one. Breathe in. We're going to do some more breaths now that are a little different. I want you to really consciously notice if you're holding tightness in your muscles, and then allow them to release. So what we're going to do this time is 3-part breathing. We're going to put our hand, I'm going to put my right hand on my stomach, my left hand onto my chest. You're going to breathe deeply into your stomach. Your stomach will rise, and then you're going to breathe, and the air will allow your chest to rise, and your ribs will come up and expand. And then on the out breath, your chest will fall, ribs will come in, and then your stomach will also drop. You don't have to be perfect on this. I don't want you to overanalyze it. But it's really about a good deep belly breath, and then a reversal of that. And again, allowing everything to just be totally relaxed. We're going to do 8 very deep breaths. Ready? Breathe in. Deeply in. Breathe in. Make sure all the muscles in your body are relaxed. Deeply in. Four more breaths. Breathe in. Notice if there's any tension. Breathe in. Any tension, go there and let it relax. Breathe in. Breathe in. And we're totally relaxed. We're going to move into our next movement, which is a hook line outside adductor stretch. When I say hook line, I just mean with our feet flat on the ground. What we'll start with here is dropping the right leg out, or whichever leg you want first, totally to the outside. Very simple, just like we were doing a moment ago. But now our other foot has the sole of the foot on the ground. We're going to keep our pelvis square rather than turning to the side. If you'd like, you can also put a little bit of pressure on the inner thigh here, and you can even straighten the leg out if that's a little too easy for you. We're going to do a 60-second hold here, and begin. So again, you can start here, foot is flat on the ground. As we progress, as you do this routine each day, you can go to the variation where the leg is straight out. Keeping our pelvis straight, relaxing the perineum, relaxing all the muscles on our pelvic floor, relaxing our hip muscles, putting just a little bit of pressure toward the ground. Remembering to breathe, to enjoy that stretch. It's a nice adductor stretch. If this is too difficult, you could put a yoga block underneath as well. We're going to switch to the other leg now. Okay, I'm going to put my other foot flat down, take my left leg out. We're going to do a 60-second stretch. Ready, begin. It's a little too difficult. Your leg can't touch the ground. Again, you can take a yoga block. You can drop it right there underneath. Still giving you a nice adductor stretch. And if that doesn't feel like much of a stretch, allow it to flop down. And you can also straighten out the other leg. Really be conscious of any tightness and allow it to release as you're breathing. Enjoy that comfortable feeling of this nice stretch. Wonderful. Now, what we're going to do is a knee chest stretch. And what we're going to do here is simply grab the shin, the top of the shin here, and bring our knee into our chest. You can keep your foot flat on the ground. We're going to do a 60-second hold on each side. So bring that knee into your chest, really pull it down toward you. The progression here you can make, if you're doing this later on in the week, as we've already done this routine several times, straighten out that other leg. So an even deeper stretch. You can also try grabbing underneath, actually grabbing the hamstring. So let's make it simple. Just push your knee to your chest with your foot flat on the ground or the leg straight out. When you think it's as far as you can go, take a deep breath in, and on your out breath, go a little bit deeper in your stretch. usually a little bit farther than you think. And as you repeat this routine, you want to go a little bit deeper. So we're going to be switching legs now to the other leg, doing a 60-second hold, and begin. Pulling it into your chest. You can keep that foot flat on the ground. If you'd like, go in as far as you can. You can't go in as far as you, that's fine. You can go in a lot further, that's also fine. Straighten the leg out if you'd like to do that. It's very comfortable. Getting a bend of hip flexor, pulling on the hip and the glutes. You don't have to stress, you don't have to flex your arms too much. We don't want to be in a state of tightness or tension really anywhere in our body on this routine. This is about releasing. This is about going to that baseline of balance and total harmony. Starting our day in a wonderful place. Wonderful job. We're going to move into a figure 4 stretch. So let me demonstrate the figure 4 stretch. We're simply going to we'll take the right leg and place the top of the foot on the top of the thigh of the other leg. And what we're going to do here, we have a couple of options. You can simply do a stretch here, that's fine. Or if you'd like a little bit more of a stretch, you can place that other foot on top of the yoga block. And we can also add a little bit by pulling on the back of our hamstring, threading our hands through. And by the end of the week, if you'd like to even straighten the leg out, that's another variation. We're going to do this for 60 seconds. Begin. So whichever one works for you, if it's your first day in this routine, you can start it here. You can push the other leg, the one that's folded over, outward some. Don't push on the knee joint, push on the inner thigh. This is just fine. Breathing. I'm going to go ahead and change it to the other variation. If you're ready for that, that's fine. If not, wait until later in the week, once you've repeated this routine multiple times. It doesn't have to be an extreme stretch. We're going to be stretching the glute of the folded leg as we're breathing. You're not overly tightening your core, not going to stress, shouldn't feel painful, or you might be going too far. We're going to switch legs now, doing the figure 4 stretch on the other leg. Simply fold it over, push outward some, and just hold it here. Just fine if you're getting started. It's a good stretch for you. If you're not feeling much of a stretch in the glute and the hip flexor, you can go to the next variation of pulling, threading your hands through and pulling in some. You'll definitely feel the stretch now in the folded legs glute. If you want to even straighten the leg out, that's also fine as you're progressing throughout the week. Again, don't feel like you have to copy me. Do what works for you. But make sure that each time you do this routine, and as you're doing the stretch, going a little bit deeper with each out breath. Being conscious of what you're doing, we can dig a little bit deeper and get a bit more relaxed and relieve that tension. What we're going to do next is called stir the pot. So stirring the pot is you bring your knees together, drop the knee then towards your body, you go out, and you come up, and you bring your knees back in, and it's just a nice flowing movement. Very simple. We're going to do that for 1 minute. Okay, get ready, and begin. Stirring the pot. I'm allowing my sacrum to come off the ground a little bit on this one, so I can get really good movement in the hip joints. As I'm breathing, other direction. Same thing, come in, back out. This one feels really good. Really nice. Pelvic floor is totally open, no tightness. It's relaxed, happy. Your hip joints are happy, you're getting some mobility there. I'm going to actually reverse it again, back the other direction. Just like that. Breathing in. Very good. So the next stretch is going to be called frog stretch. On frog stretch, we're in a very similar position. But now we're going to grab our ankles on the inside of our leg. Grab the ankle. If you're really flexible, you can just grab outside of your feet if you like to. But the ankles are fine, even if that's too hard, a little bit on the shins. And we're going to be just pulling in and allowing our legs to flop out. As we keep our back flat to the ground, we don't want to actually lift up off the ground on this. We're going to hold this for 1 minute. Alright, frog stretch. You're going to really feel and notice any tension in your pelvic floor here. And allow your legs to flop out. Pull your heels a little bit more towards your perineum. Really nice stretch for the glutes, the inner thigh, also the pelvic floor muscles. As you're breathing, again, don't lift up off the ground like this. I want you to stay down. I want you to breathe into your stomach. I want you to breathe into your pelvic floor. Deep mindful breathing allows you to actually bring more energy into that area. Healing energy, and out with the stress, out with the tension. We're going to do something called windshield wipers, and we're going to do this from this lying position. So all we're going to do next is actually rotate our legs across, bending our knees, just like this. Very simple. We're going to do that for 1 minute, and begin. This is called windshield wipers. I really like this one. Rather than just letting them flop, have some level of control, and towards the end of this movement, push the inside leg downward a little bit more. Get a little bit more of a stretch. You'll actually feel a little bit of a twist as well in your obliques. And your lower back, which is also nice. So go ahead and continue to move. It's not really fast. It's a slow movement. Breathing out. Feels really, really good. Just enjoy the moment. Don't think about anything else other than relaxing and being calm and enjoying these stretches. We're going to do a head to knee pose. We're not actually going to go all the way head to knee this time, though. If you have a towel or a blanket with you, this will be the time to grab that. And this is just going to give us a little bit of elevation, a couple of inches, really all we're doing here. What we're going to do is use our belt or necktie or whatever it is that you're using, and it's going to allow us to get a little bit deeper of a stretch. What we're going to do is take one leg. I'll take my right leg, put the sole of my foot to the inside of the thigh. I don't have to go really, really, really far, but I'm also not way out here. The key here is having a straight back. Okay? And what we're going to do is take a deep breath in. We're going to breathe out. As we breathe out, we actually lean forward a little bit while maintaining a fairly straight, erect back. And then, if you have no tension in your lower back, we'll go down a little bit further. But we're going to do 2 minutes on the left leg. Taking a deep breath in. Lean forward some. I'm hinging at my hips though. Go comfortably into this. We don't have to dive all the way forward as far as we can immediately. You can round a little bit now, as long as there's not a great deal of pain in your lower back. We're going to start over again, because I really want us to get comfortable with the understanding that we want an erect back, a deep breath, and hinge forward. These forward bends are incredible they're very beneficial for the central nervous system. But having that straightness is important to get the benefits. It's going to allow energy to flow up and down the spine, throughout the whole nervous system. If there are any kinks, if there's anything that can't flow to your pelvic floor or other aspects, other parts of your body, creates issues. We're going to go a little bit deeper now with our forward bend, if you can. Remember with an out breath, you're able to go in a little bit deeper with your stretch. This is one of those stretches that I want to challenge you to go a little bit deeper if you've done this routine a few days in a row. Deeply in. A little bit deeper now. About 12 seconds left. It might be uncomfortable, I wouldn't say painful, but it's a deep stretch right now. Hold it for another few seconds. We're almost done. Time is up. Oh, that's a really good one. We're going to switch legs now. Pull the left foot in, right leg goes out. Go ahead and lasso this foot. Get ready to go. 2-minute hold. Taking a deep breath in with an erect spine. Hinging forward. You want to go a little bit more with your strap or wherever you're holding. Also, remember to keep that left leg as the leg that's folded sideways toward the ground rather than allowing it to come up. Let's go a little bit deeper now. It's really, really healing. Very good for our spine, nervous system. It's also good for our abdominals and our stomach and our organs. With about 1 minute left, we're going to ease up some. We're going to start back from our erect position. Hinging forward. There's no pain in your lower back. Go a little bit deeper now. It's somewhat of a round. But that is because we hinge from a straight erect position originally. Last 30 seconds. This is the work. Might be a little uncomfortable. Giving your body the time it needs to heal. You're pushing yourself a little bit more, going a little bit deeper. You're reminding yourself not to hold any tension. You have 5 seconds left. We're almost done here. Very nice, very nice. We're going to do a butterfly stretch. For the butterfly, we're going to put our feet together, our soles together. We're not just going to go all the way in, like maybe you've done in the past. We're actually going to keep it out some. Doesn't have to be too extreme on this one. And we're actually going to put our hands behind us and hold this for 2 minutes. Now, I do want you to bring your legs toward the ground. Keep your back pretty straight. My chest is up and out. But I also don't want you to become overly tense in your body. Feel a nice stretch on the inner thigh, which the inner thighs are connected to all the pelvic floor muscles. That hammock that holds your body up. And you're breathing in as well. Throughout the week, as you're doing this routine and you're repeating it, you can make this a little bit more difficult by pulling your legs in and sit closer towards your body. Got 1 minute left. Remember, there should be some level of uncomfortableness and a stretch. You shouldn't just be sitting here totally relaxed like you're watching TV per se. There's some stretch happening, but you're conscious and aware that you're not tensing muscles up, that you're not contracting. Got about 25 seconds left. Take a deep breath in, go a little bit lower. You can do it. Very nice. Everything in your pelvic floor, your glutes, it's all relaxed. It's all just sinking into the floor. Your hands are sinking into the floor. Your shoulders aren't tense. Alright. What we're going to do next are the windshield wipers that we did earlier, but from a seated position. So we're just going to stay up here, and we do our windshield wipers for 1 minute. And very nice hip opening, really good. In between, deep stretch type of movements that we like to add in here. On the seated variation, I like to get a little bit more of that rotation on the obliques and the lower back. And my legs aren't really far out, but they're also not too close to my body. Again, this doesn't have to be perfect. It should feel really good. Still breathe. Let your breath kill you. Okay. Our last exercise today is going to be child's pose. Child's pose, maybe you've done this one before. We're going to start out sitting on our hips. That's a little too much for you. You can take your towel or your blanket, give you a little bit more support there, a little bit more distance. And also on your child's pose, you'd like to put a yoga block or a pillow to allow your head to rest on that, that's fine. But what we're going to do is a 2-minute hold in child's pose. Ready? Begin. So I'm just going to put my hands on the ground, stretch them forward, walk them forward. And keeping my knees pretty close together. This isn't the widened version of child's pose. If uncomfortable for your head or your neck, you can put your forehead on the yoga block. Otherwise, I'm just going to let you really enjoy the stretch, not to talk too much. I'm going to let you do some very deep breathing. Release the back, release the shoulders, release the pelvic floor. Breathe in to the pelvic floor. You're doing really good. Keep it going. If you want to walk your arms out a little bit further, that's fine. As long as there's tension in your body, let it go. And then slowly. So that's the end of our routine today. If you'd like to just lie there, lie down on your back, that's a great way to continue on after this. And just allow your body to feel this amazing feeling of relaxation. Don't have to get up right now. Just feel wonderful, feel open, feel balanced, feel released, feel relaxed. And I look forward to seeing you in the next routine. Have an amazing day.
High potency skincare.
Hold
now
on
for your
the
whole
phone.
body. New Dove Cream Serum. With dermatological ingredients like niacinamide for 48 hours of regenerative moisture. New Dove Cream Serum.
Welcome, sir.
Hi there, my name is Dr. Bree. Hi there, my name is Dr. Bree, and today I have a really cool video for you that I hope is going to give you an
This is Vancouver, British Columbia, the epicenter.
When I moved out of home at the
Frozen shoulder routine. Frozen shoulder routine.
everyone, I'm Dr. Amy Kanata.
And I'm Ashley.
Ashley, what are we going to be talking about today?
We're going to talk about how you can tell the difference between a meniscal tear and an ACL tear at home.
Before we get started, maybe the folks want to know, what is a meniscus and what is an ACL?
So your ACL is a ligament in your knee, and your meniscus is the cartilage between the two bones in your knee at the joint. How could you tell the difference without using any test between a meniscal tear and a ACL tear?
Oh, that's a great question.
And honestly,
Hello. Hello, my name is Young Fox, and I'm a primary care internist and a recreational runner at the University of Michigan. And this is Anthony Pariano, who's a marathon runner and also coach of the Huron High School cross country team. And we are here today to talk to you about knee.
Diagnosis actually comes down to, how did your knee start hurting? Was there a traumatic event? Did you slip and fall? Were you playing sports? Were you playing basketball? Were you playing soccer? Were you planted your foot and turned? Did you hear a pop? Typically, when you hear a pop, it means something tore. So part of it is your history. How did you do it? Was it traumatic, or did it gradually come on? Typically, with ligament tears, you'll have a traumatic event. You'll twist, you'll pop. You'll be playing sports, you'll be hiking, you'll hear that pop. You'll feel that pain, and your knee will start to swell. With a meniscal injury,
Hi, my name is Dr. Andrea Ford. I am a physiatrist and pain specialist in Toronto, Canada. If you have been diagnosed with hip or knee osteoarthritis, your doctor probably told you to go and do some exercises. Today, I'll show to you the exercise that I recommend to my patients with hip and knee OA or osteoarthritis. The type of exercise is for
to try to help people get out of chronic pain and help get out of chronic pain.
Hi everyone, I'm Rosie and welcome to Box Yoga.
Boat BC presents the Vancouver International Boat Show, January 29th through February 2nd at
Both stretching and strengthening exercises are very important for recovering from calf strain injuries and can begin once the initial acute phase is past and the pain allows. Exercises should always be done pain-free, and we recommend seeking professional advice before attempting any rehabilitation exercises. Active stretching is used in the early stages of a calf muscle injury as it applies a gentle stretch to the muscle. Muscles work in pairs, and by contracting the muscles in the front of the lower leg, the muscles exercises to stretch calf muscles should be done both with the leg straight and bent. Bending the knee enables the deeper soleus muscle to be stretched more easily as the larger gastrocnemius muscle is relaxed. To stretch the big gastrocnemius muscle, the back leg must be kept straight. Hold the stretch for up to 20 seconds and repeat 2 to 3 times. Stretches can be done against a wall, on a stump, or anything similar, as long as you can feel a gentle pull or stretch in the muscle. This is done by performing the same stretches but with the knee bent. Stretching exercises should be repeated 3 to 5 times per day, and always pain-free. Strengthening exercises can begin as soon as they can be done pain-free. However, if you need to be on your feet a lot anyway, bear in mind the calf muscle will be exercising naturally. In the early stages especially, it is more important to allow healing than to increase the load too early and risk re-injury. Exercises should be pain-free. If there is any pain during, after, or the next day, then reduce the load or rest a bit longer. Using a resistance band whilst sitting is a gentle exercise which is suitable in the very early stages, especially following a more severe injury. Another early stage strengthening exercise is the seated calf raise. More advanced calf raise exercises using body weight can be done against a wall or on a step. Perform straight leg exercises to target the larger gastrocnemius muscle and isolate the lower soleus muscle by bending the knee. Finally, more functional and sport-specific strengthening exercises are done. These involve explosive, dynamic movements, which relate more closely to specific demands on the sport. For more detailed information, visit sportsinjuryclinic.net. Don't forget to like and share.
ODBC presents the Vancouver International Boat Show, January 29th to February 2nd.
How is it that your psoas and jaw can combine to create postural instability and musculoskeletal pain and a lot of other horrible symptoms? Well, it's through the autonomic nervous system. These connections is what this video is. Before I get into the details, here is the big picture. Ventral vagal dysfunction. Just think of front of the face, the mouth, your tongue, your larynx, your vagus nerve, your visual system, your auditory system. All of that. When something goes wrong inside there, that ventral vagal system, it increases sympathetic trunk activity, which is your torso, which means increased sympathetic trunk creates extension. Extension of the lower back will tilt the pelvis forward on one, which is what we call the left AIC pattern, as defined by the Posture Restoration Institute, or both, which is called the bilateral AIC pattern, or PET pattern. So, that means that increased sympathetic activity, trunk activity, increases hip flexor overactivity, hypertonicity. So your hip flexors get overactive, and your lower back gets overactive, which holds you in this state of extension. Now, the big question comes, how is it from the cranium and the jaw? Well, now I'm going to delve into the details. This young man has a rib cage that is extended, he's overarched, and thus he cannot pass his shoulder internal rotation test. He also has a pelvis that is forward on both sides, actually. I only show two tests. I only show the left arm and the left leg, but his pelvis is forward on both sides. He's in sympathetic extension tone overactivity. The only way he's going to pass this test, because I know his jaw, he has a TMJ issue. His jaw was not positioned properly, it was off to the right. The only way he's going to pass this test is by taking a little plastic mouth guard and putting it over his bottom teeth. So, the moment his brain senses something different between his teeth, the sympathetic nervous system overactivity immediately decreases. The sympathetic trunk extension activity goes away, his pelvic tilt goes away, and he can now pass his shoulder and his leg test, and that's what you're going to see. So his left shoulder does not internally rotate, his left leg does not adduct, doesn't go down, he's extended, Now he's going to put a little plastic mouth guard in over his bottom teeth. And immediately, he can adduct, his hip flexors turned off, and his back extensors and the front of his neck also relax. Why was he stuck in this sympathetic fight or flight type of situation? Well, it was coming from his jaw. His jaw was off to the right, and I know that's a big problem. And you'll see in later on in the video pictures of me. I was in the exact same situation. When that jaw is off to the right, that body, that neck is influenced into a state of tension. It pulls the head and neck forward, extends the rest of the body, and now you're stuck in this sympathetic trunk activity. So his ventral vagal dysfunction, which was coming from a jaw that was not positioned properly, that his own brain was sensing as a threat, that ventral vagal dysfunction was fight or flight and extension tone. It promoted fight or flight. This TMJ, temporal mandibular joint. So first you have to understand the autonomic nervous system, because that's the player. His body, and anyone with this type of issue, their body is being held hostage by the sympathetic fight or flight system. So the ventral vagal system, it's a better way of explaining the fight or flight phenomenon. Basically, the trigeminal nerve, that's the mouth, the facial nerve, self-explanatory. But the trigeminal and facial also influence the hearing muscles of your ear, the glossopharyngeal, so the back of your throat and the back of your tongue, your ability to swallow. All these are very important things. The vagus nerve, who doesn't know the vagus nerve at this point? That's the major parasympathetic, the rest and digest nerve. And then the accessory nerve, which is really interesting. We'll get to that separately. The accessory nerve is the 11th cranial nerve, and it controls your SCM and your upper and your trapezius muscles, which allow your head to turn and rotate so your brain can figure out where you are in space. So taken all together, the ventral vagal system controls or is responsible for orientation. Where am I in space? Remember, you might see yourself where you are in space, but your brainstem, communication, humans, we communicate. Language all comes from the front of the face and obviously the body. And feeding, swallowing, eating, all of life happens with this ventral vagal system. And whenever something goes wrong in that ventral vagal system, like TMD, temporal mandibular dysfunction, because of a TMJ that's not positioned properly, however that occurs, or teeth that have been pulled, especially molars and canines, whenever that happens, that's threat. And once your brain is threatened, it promotes extension, fight or flight. This is what the cranial nerves look like. There's a lot of them. And they all go into the midbrain and the brainstem, which is the autonomic regulator. So your fight or flight, whether you're in fight or flight or whether you're rested and digested, is happening at that midbrain and brainstem. And that's all ventral vagal system. All the information your brain is collecting, whether you're in a threatening environment or not, or you're in a peaceful environment. That all goes back to that midbrain brainstem area, which then regulates your heartbeat, regulates your breathing, prepares you for fight or flight. Now again, you see all these nerves, and those are not just the cranial nerves, those are also, we'll get to them, the brachial plexus, the cervical plexus and the brachial plexus. We'll get to that. But what I do show is the upper trapezius and the SCM, the sternocleidomastoid. Whenever you're threatened, and that's part of the ventral vagal system. So whenever this ventral front area is threatened by the situation you're in, a tooth that got taken out, a jaw that deviated, your own voice got a little bit thrown off, you can't swallow anymore, you had a throat injury, that ventral vagal system is threatened. And when that happens, the SCM and the upper traps pull your head and neck forward into a forward head position, and then simply that promotes neck breathing. And neck breathing, that's disordered breathing. Neck breathing is fight or flight activity. And it doesn't even have to be something, an insult to the front of the head or the face or something. It could be you sat too much. You sit in a chair too much. You're too stationary. You sit and stare at computer screens. That's all ventral vagal. Head and neck fall forward, and you hyperfocus your eyes. That is the autonomic nervous system. So, not everyone who ends up in this consistent state of tension, fight or flight, has anything wrong with the oral cavity. Just because your hip flexors are tight doesn't mean it's coming from up here. It could just be a forward head posture that's putting you into increased sympathetics, which then increase the hip flexor activity.
This respiratory illness season, practice healthy habits to help protect you and the people in your life. Now's the time to get your flu and updated COVID shots. Remember to cover coughs and sneezes and stay home if you're sick. We can all do our part.
My life is full of questions. How do I see my name, Lucy? So tired. Do I need to appreciate guacamole? So tired.
Why don't you even buy napkins?
Thankfully, Ty's the answer to almost all of them. To scratch my eyebrows? Like that one.
For all of life's laundry questions, it's got to be Tide.
The best part about being your own boss, you get to dictate what you dedicate your time to. Which is actually a lie, you don't. My favorite zero feature is the bank feed. It's great to be able to have all of your different bank feeds go into one place.
Power Homeschool, the leader in providing online lessons to families homeschooling their children, is pleased to announce a major upgrade. Introducing Accelis HD, the new high-definition edition that delivers improved video lessons, homeschooling tools, and reports in a new mobile-friendly platform that parents and children love. Accelis HD comes with a host of new available features that Power Homeschool families can choose to adopt. It features a modern and intuitive interface, along with enhanced tools, including video and assessment retake tools, making it easier than ever for students to get extra help or restart a practice quiz or an exam. Enhanced student goal features with completion notifications. An all-new parent dashboard where parents can monitor all their students from one place. Upgraded student reports for parents to monitor and report progress. And advanced course transparency tools that give parents more learning resources and control. To aid with
So once that head and neck fall forward, for any reason, whether it's, and you just get stuck in this loop of disordered breathing, tension, and then eventually you develop an unstable.
This is me.
It could just be a forward head posture that's putting you into increased sympathetics, which then increase the hip flexor activity. So once that head and neck fall forward, for any reason, whether it's something with your mouth or not, or just too much sitting and too much neck breathing, your spinal sympathetic chain, which is going from the top of your spine, T1, all the way down to L2, which is the lumbar spine. Right about here-ish. O1, 2, 3, 4, 5, and the sacrum. Right? Those are the fight or flight muscles. Think back extensors and hip flexors. So yeah, the moment your cranium or the mouth, the TMJ, because that's the discussion we're having right now. Once that's threatening and your brain says, whoa, that's not good, that sympathetic nervous system kicks in, you extend, the rib cage goes up, your pelvis falls forward, and now you have back extensors, lower back muscles, and hip flexors that won't shut off. And those are pelvic destabilizers. And now once your pelvis stays unstable because your brain is saying, no, this is a threatened situation, you lose stability in your pelvis, you lose your hamstrings, your glutes, and your pelvic floor, and I'm going to show that. And now, again, you just get stuck in this loop of disordered breathing, tension, and then eventually you develop an unstable pelvis, which creates even more of this fight or flight tension behavior. Real quick, if you like this video, you think it's interesting, could you share it, subscribe, comment, give it a thumbs up, anything to promote this, because a lot of people are still in the dark about this situation. Now this sympathetic trunk, you can see it all in the front of your spine, and you can see how it really starts all the way up here and starts to drop all the way down. That's the sympathetic chain. It also is regulating heart, lungs, organs, gut, genitals. So your sexual function as a male or female will be greatly impacted by the sympathetic trunk. If your head and neck fall forward, let's say because of TMJ, a jaw that's not positioned properly, your brain finds it threatening, or simply the jaw is not positioned properly and the neck muscles are now not positioned properly. As you go into extension, you get to shift it over to your right side, because remember, we know that bigger right diaphragm is underlying everything. So we're all right dominant. We go to that right side, we extend, and now that sympathetic trunk is overactive. Your vagus nerve never gets to calm everything down. It never gets to exert its influence. The more sympathetic you are, the more your vagus nerve receives its activity. But it's the vagus nerve activity that keeps things calm. So the way fight or flight works is you're happy, you're in a parasympathetic state, you're sitting, you're in your car, you're singing your favorite song, you're nice and relaxed, your vagus nerve is firing, everything's cool. Someone cuts you off, and all of a sudden you go, whoa, what the F? That's sympathetic. Once that occurs, the vagus nerve withdraws its tone, its influence, and your sympathetics come into full blast because you were threatened. Now, once that situation ends, you're like, what a jerk, but he speeds away and you get back to your song, that's when the vagus nerve should start to exert its influence again and start to calm everything down. But when you're in a forward head posture and you have pelvic instability at this point, and your neck breathing, and your brain is saying, oh, that missing tooth is a real problem. I need that molar back because I can't sense where my head and teeth are or where my jaw's going. Then the vagus nerve never gets to reassert its calming influence, and that's the problem. That's how you get stuck in that cycle of tension. The vagus nerve simply doesn't get to re-exert its calming influence. So it's not about treating the vagus nerve, it's not about treating the vagus nerve, it's about what's feeding into the dysfunction that the vagus nerve is not allowed to exert its calming influence. Now, some people do know about this. Not a lot, unfortunately, but there are. And in fact, this little passage here comes from this book, Face to Face with the Face. That's what this is all about. I think they're in England, actually. Thomas Attlee, he's in London. I don't know how old it is, but so this is known. Cranial sacral therapists know this. This dentist works with cranial sacral therapists to try to deal with this interconnectedness. So just see what he writes. He says, the teeth and jaw are an integral part of the rest of the body. If they are treated in isolation without awareness of that interconnection, then the benefits may be limited and the effects potentially disruptive. An uneven bite or mouth movement may lead to unbalanced muscle use, jaw muscles, throat muscles, neck muscles, with dominoes through the rest of the body. And you can have all these types of compression of the jugular foramen, impinging the jugular vein, the spinal accessory nerve, the vagus nerve, headache, ear pain, tinnitus, respiratory, cardiac, digestive disturbance, all of it. They know this. I know this. I've experienced it myself. Postural restoration knows this. This is what we deal with all the time. But it goes further than that. It doesn't stop here. It goes all the way down the pelvis, all the way to the ground. And that's what's so fascinating. This is a vestibular system input, the upright balance issue, how your brain orients, how your brain figures out where you are in space, how it moves you forward is all influenced by the head and the jaw and the teeth, as he's saying. So the problem with extension is, in terms of movement, your ability to move forward without restriction, you need hip flexors that can alternate between being on and off. That psoas is turned on and off to help move the pelvis forward, to help rotate your body to the opposite side, and to help turn the leg out. But really, who cares about the biomechanics? The biomechanics can't work unless your body is in a non-heightened sympathetic state. All movement is sympathetic. So it's not like you're not moving in a rest and digest parasympathetic state. But it's not an all or not. You're not either in sympathetic or in parasympathetic. It's kind of described like that quite often, but it's not. There's a ratio of everything. It wouldn't even make sense. So, but your hip flexors have to go through cycles of on and off on alternating sides so that the pelvis can move forward and the spine can rotate. Otherwise, you can't move. Otherwise, you're extended. So if both sides of the pelvis come forward at the same time, you can only do one thing: extend. You can't move. You're going to move forward, but with strain. And eventually, it's going to start to hurt and break your body down. So the problem is when you're extended, the somatic system, like, hey, you're goal directed. I want to do this. I reach for this. You'll still reach, but because of the extension and tension and the limited movement of your body, you're going to strain to do it, and over time you're going to start to use the wrong muscles to do it, and that's what starts to hurt. Very normally, the right arm, once you're in this position for too long, extended for too long in this pattern, your neck really starts to take over the right arm. You're not going to be using your serratus muscles and your lower trapezius and your triceps and your biceps. they're not going to be, because your scapula is not going to be positioned properly. So the neck and your lat will start to take over the use of the right arm. So, your cervical plexus, these are the muscles of the neck and diaphragm, all up through here. Those muscles, and you're going to see a picture of them, those nerves control all these muscles. Well, once that head and neck comes forward, you could very easily, first of all, you're going into extension as you do it, but you could get compression in any of those nerves. Those nerves may not fire optimally. So there's a lot in that area, and there's no open space. So that could be affected. That could be thoracic outlet syndrome type of symptom. Then you have the brachial plexus, which C5 to T1, so it's the mid-neck down to the top thoracic vertebrae. Muscles of the shoulders and arms. So here's a picture of that. Shoulders, upper arms, lower arms, and hands. I mean, it's on both sides. Just one side is maroon, the other one is yellow. But there's a ton. Look at how many of those nerves go through between the collarbone and the rib cage underneath. The moment that head and neck come forward and you extend, that space gets smaller. So in postural restoration, we're always trying to expand the rib cage with air to clear up space so those nerves, conduction and function, can go back to being normal. The sacral plexus, so the L4 to S4, so your lower lumbar spine, your lower lumbar spine, and to the sacrum area, pelvic floor, glutes, lower legs, feet. Those are pelvic stabilizers. When you're in the state of extension and your thorax is in that extended fight or flight state, and your hip flexors are on, and your lower back muscles are on constantly, you lose the ability to use your pelvic floor to breathe with your diaphragm. So you can no longer diaphragmatically breathe. You lose your glutes, you lose your hamstrings. And those muscles are needed to work with the hip flexors. The hip flexors are not bad, they just need to be used appropriately. But hip flexors need glutes and hamstrings to be able to alternate you from side to side. So if I'm taking a step and I want to swing my right leg forward, I'll use my right hip flexor to swing that leg forward as my pelvis is turning to the left, as that left hamstring and left glute are stabilizing that left side. And then you do the opposite. So you have to have alternating cycles of hip flexor and hamstring, glute, pelvic floor activity. But if you're stuck in a state of extension on one or both sides because of extension tone being driven by the jaw or anything, or just disordered breathing, doesn't matter, that is compromised, and now the pelvis becomes, those pelvic stabilizers no longer work properly. They'll work to a degree, but not the way they're supposed to. And now you become less stable in your pelvis because your hip flexors are taken over. And there are pelvic non-stop or overactive hip flexors are pelvic destabilizers. So your pelvic stabilizers don't get to activate. So the gentleman in the video, his hip flexors were so overactive because of his jaw, he could not feel his hamstring or his glutes in any type of postural restoration activity. And here you just have an image of that sacral plexus. That sciatic nerve is gigantic. Okay, so anytime that pelvis is forward on both sides, and the legs have to externally rotate on one or both sides to compensate for the pelvis that's forward, that sciatic nerve could be impinged. And a lot of people have sciatic pain. It's really not that hard to figure out, to be honest. It's pattern that we're talking about, extension.
If you hate aggressive scents like
Maple bacon musk.
you'll love Downy Light. When you add it to your wash, it gives everything the gentle, nature-inspired scent of ocean mist. Downy Light breathes life into your laundry. The things I want to see, the things I want to do. Starting here, investing with RBC.
When it comes to reaching your goals, performance matters. Maximize your return on life, and you can get $300 when you invest with RBC. Boating BC presents the Vancouver International Boat Show, January 29th to February 2nd.
Okay, Chad, sometime out here. I'm
Island, Western Canada's largest sale for boats, accessories, and more. For info and tickets, visit vancouverboatshow.ca.
This is what pain looks like when you keep moving with Aleve. Just one Aleve gives you up to 12 hours of uninterrupted pain relief. Aleve, one pill, 12 hours. And for effective topical pain relief.
Good night, everybody. Keep on struggling. We'll see you tomorrow. Good night. Goodbye. Goodbye.